enjoying the previous episodes of AI Chronicles. And for this new episode, we'll be talking about the fancy buzzwords like semantic search, RAG, and maybe a quick demo. To do so, I invited Casper, whose last name I'm going to refrain from saying so I don't butcher it. He is a developer advocate at Quadrant. Hi, Casper. Hope you had a good time during your San Francisco visit. How are you doing?
Yeah, I'm fine. Hello, Sonam. Welcome, everyone. Yeah, that was a real pleasure to meet you and so many great people in San Francisco. That was a really great experience. And my last name is Lukavsky or Lukavsky, but yeah, I have to say this is pretty hard.
Okay, yeah, I'm still not going to repeat it, but thank you. Well, when we discussed having a podcast conversation together, I was thrilled when you mentioned about semantic search, RAG, and all those cool words. So I have worked on something similar myself, but I'm very curious to find out how everything plays out when it comes to scaling for large scale and especially productionizing. So if you're ready, let's get started.
Sure, let's do it.
Awesome. Okay, so let's start with basics. How would you define semantic search?
Yeah, so semantic search is just a different way of finding some relevant documents. So we had been using keyword-based search methods for years, and tools such as Elasticsearch or OpenSearch, but even some simpler ones were providing us with some relevant documents. But here, the finding the best matches was mainly based on the keyword presence. So our queries or queries that we were receiving from our users had to match the same words that were used in the documents they were searching over. So semantic search is utilizing some neural networks to create vector embeddings. And those vector embeddings have this useful property of being close to each other if they describe similar objects. So thanks to that, we can now use different terminology in our queries and in the documents. And, and if we use a powerful model, it should be already able to capture the real meaning and the
Mhm.
intent, not only the keywords used.
Gotcha. That makes sense. So I know we have been hearing how LLMs have been hallucinating and giving misinformation. So r- now we have RAG, retrieval augmented generation. Can you maybe talk about it a little bit?
Yeah, definitely. So basically, the main problem with LLMs is, as you said, the problem of hallucinations, which actually this is a problem of generating some answers that cannot be justified by the training data. So actually, the LLMs are just trained in order to predict the next tokens in a sequence, and that's it. But since they have lots of parameters, they are able to capture some relationships between the tokens or words, and thanks to that, generate some responses which actually make sense. But sometimes they just making up things which are not true. And retrieval augmented generation is one of the ways to mitigate that risk. I'm not saying that RAG solves the problem of hallucination, but it actually tries to use these powerful capabilities of large language models to rewrite a particular piece of text and extract the answer or to summarize the facts that we provided. So retrieval augmented generation is a way of using LLMs to well, actually forcing LLMs to use the context we provide. And retrieval is a crucial component for that because retrieval is actually just some sort of search. And semantic search goes so well with large language models because in both cases we want to have natural conversations. So we want to be able to find some relevant documents without worrying much about the keywords, and that's why in retrieval augmented generation we mostly use semantic search, but that's not the only possibility. We can also use the old methods. This is only about how we are going to provide the context into the prompts that we send to the LLMs. That's it.
Mm, nice. So do you think with the LLM hallucination, RAG can be used in combination with other techniques like fine tuning and prompt engineering.
Yeah, definitely. I'm not sure about fine tuning. I have to say that like people speak a lot about fine tuning, but this is
Yeah.
so expensive. I'm not sure if I
Yeah.
have ever talked to anyone who would be doing fine tuning on larger scale. I know that people try to do it with the smaller models, the
Mm-hmm.
open source ones. But if you wanted to to fine tune one of the GPTs from OpenAI, you would need to pay at least $2 million, something
Oh my
around it.
God.
This is
Yeah.
definitely too expensive to be done. However, it is doable. And also,
Mm-hmm.
there is this is actually one of the things that I read today in the morning, that there are some strategies of combining retrieval augmented generation with fine tuning. They're called retrieval aware fine tuning. And
Oh
this
my
is
gosh.
actually a technique that might be done with some smaller models, and that
Mhm.
brings some facts retrieved from some knowledge bases and use them during the fine tuning process. This is pretty interesting because those smaller models,
Hmm.
while trained with this technique, might easily beat GPT 3.5 in some specific domain. So that goes well together, and prompt engineering is probably the easiest way
Hmm.
the easiest to combine with retrieval
Right.
augmented generation.
Got it. So we have RAG and now we have RAFT, retrieval awareness, fine
Exactly.
tuning. Jesus. Okay,
Yeah.
too many abbreviations. Okay, all right. But I'm glad you shared. I did not hear about it yet, so maybe I'll find it out.
This is pretty new topic. I may
Mm,
probably send some links to the
sure.
paper that I read, but that sounds really interesting, and that's something
Mm,
that might be done even by small or medium-sized companies.
interesting. Okay, RAG versus RAFT. Got it. Uh, moving on to talking about more about semantic search. There are plenty of use cases. So I was wondering, do you have any favorite use case that you'd like to share?
Yeah, definitely it's not RAG. I know that people are so
Hmm.
excited about RAG and everyone wants to implement RAG nowadays. But
Me being
I
one of them.
Yeah, no, this is really cool idea, of course, but there are so many chat over your PDF demos, and usually just a few people just go beyond that. I would say that well, first of all, semantic search is not only about finding some relevant documents. Actually, that's the algorithm, but it might be used to solve problems such as classification, even extreme classification, because this is a pretty simple strategy of finding the most similar objects in our database, and then by simple voting choosing the right class for the example. And actually, I saw so many applications of semantic search to build extreme classification, for example, in medicine, but also to perform reverse image search.
Hmm.
So I would say extreme classification is my favorite, but also things such as anomaly detection are
Hmm.
pretty interesting, and I feel way underappreciated.
Interesting. Could you give an example of extreme classification?
Sure. Yeah. So when we are still doing supervised learning to
Hmm.
train some models, so they are able to recognize particular classes and assign labels to new examples.
Right.
This set of labels was just fixed for the training phase, and then we
Hmm.
were only able to detect this classes that we trained the model for.
Hmm.
Extreme classification is pretty interesting idea that we can change the number of classes during the inference,
Oh.
because it's not based on any network which is solely trained for that particular task, but it's more like we have a set of objects and we have a network that is able to create embeddings. And the objects we have may belong to various classes, and we can add some new classes, and the classification pipeline is based on k-nearest neighbors. So we
Okay.
let's say we have a set of classes and we assign those classes to images, but then we have a set of new examples that are completely different. For example, let's say we work in e-commerce, we sell clothes, and there is a new collection, maybe, and we want to classify those new items to a completely different class. So then we just put those examples into the vector store, and in the metadata, just mark that they belong to a different class. We put a name of that class, and then the inference phase goes as following. We select top k nearest neighbors. Let's say we select 100, and then we
Mm-hmm.
select the most common classes over those examples that we fetched. So actually, we can modify the examples in a vector store, and then the number of classes or the set of classes that we support is based on what we already have. So this is pretty interesting because if your embedding model is able to capture just the semantics of the objects, it's all good because it will be working no matter how the classes are varying over time.
Got it. Thanks. Yeah, okay, learning a lot new things today. That's awesome. So, speaking of building these applications, how would you go about scaling them on larger scale?
Yeah, so definitely the good thing about all the semantic search applications is that they usually rely on HNSW algorithm, which is I'm not gonna go much into details, but it's basically a graph-like structure. And this graph-like structure might be divided into multiple segments. So these segments might be just spread across a whole cluster of machines that you use for semantic search. So scaling them is pretty easy because all you have to do is to just put some more machines with the growth of the number of objects you have, or if you want to support concurrent requests using the same vector store. So scaling the applications that of semantic search applications is, I would say, solved already. It's only about choosing the right tool that is intended to be scalable enough.
Okay. So when you are building these applications, semantic search applications specifically, I know we spoke a little bit about the LLM has a hallucination. That could be one, but what are the other challenges do you see when you're building such an application?
Yes, for sure. The main problem that I see is that people just take one of the random models that exist and start using them like blindly. The problem is that if you take, for example, OpenAI embeddings, which are pretty good, especially for English, it's all fine. But once you go into production and your users start to use a different language, you will simply struggle. Or if you take one of the general usage embedding models and apply it for a completely different domain, let's say you want to perform search over some medical data. There are some chances that the model won't be the best choice for your specific data set. And people usually don't evaluate that from the very beginning, but they are just choosing some random model which is available out there, or maybe the default of the framework they use. And it's usually OpenAI embeddings. So that's one of the challenges that I see quite often.
Hmm.
Also, um, it's except for the evaluation, it's also about choosing the if you choose a framework, there are plenty of them available. And if you want to build a retrieval augmented generation pipeline, there are some interactions with LLMs, and there are some prompts that you need to send. And I like to call those people victims of the default prompt, because those high-level frameworks usually hide a lot of complexity and a lot of prompts. So if you are not aware of the prompts that are sent to the LLM, you have actually no control about the process. There are so many AI startups being built nowadays which only rely on good prompts that they were able to figure out. So those two, I would say, are the most common ones.
Got it. So taking these challenges and all the things that go in building a production level application, how do you think RAG is used in semantic search and then, if pushed into production, like the whole enchilada?
Yeah, so basically, if you want to build an application using RAG or semantic search, there are a few components that you need to choose. So first of all, since you want to perform the semantic search over some documents, you need to have an engine that will provide you with the semantic search capabilities. So this is the first component, and this is usually one of the vector databases available out there.
Hmm.
There is also an LLM, large language model, that you want to use for that, and the embedding model. And you need to have a way of deploying those models unless you want to use one of the SaaS solutions such as OpenAI or Cohere.
Hmm.
Um, but this is actually the whole stack. Of course, you can combine it with some additional data sources. You also need to build a pipeline of ingesting some new data into the vector store. But there's also so many frameworks that I mentioned already that help you just glue those pieces together, and they ease that a lot. So I would say two models, vector store, and some sort of library that will just combine those tools together.
I guess in that case, maybe LangChain or Llama Index would be helpful.
Yeah, definitely. But there is also Haystack from Deepset
A
that I
haystack,
really
yes.
like. They have recently published the new version, which is really,
Hmm.
really great, and also eases a lot of things. So I would say those three are definitely the top three ones.
Okay.
And but yeah, if you have some other preferences, it's also fine. But you should be aware of what are really the
Right.
interactions between you and the LLM and the other components.
Yeah, that makes sense. So, you build everything, you bring in all the components together, and then you orchestrate everything using either Haystack, LangChain, or whatever. So, next step, as the computer science scientist in me, I would say, ask like, how should one optimize this process of building this application, including RAG?
Um, Yeah, so first of all, you need some sort of traceability.
Mm.
And this is also related to something that I've already mentioned. I mean, if you don't know how your interactions look like, you might be losing a lot because
Mm-hmm.
maybe you'll be just overpaying for the prompt sent. So you are paying for tokens used, so you might be just overpaying because there are too many calls to LLMs. So some sort of traceability tools such as Langsmith should be already in place once you start implementing retrieval augmented generation or anything based on LLMs. Mm, what's more, well, it's also about, but it's not related to any specific framework, but it's also about how much you are able to spread the load across the different machines. Definitely, this kind of applications are pretty heavy. I mean,
Mm-hmm.
you need to have multiple machines if you really experience some high loads. So the easier it is to do some load balancing for the framework, the better it is for the whole application. And also, do not forget some standard tools like logging and
Yeah.
tools for error tracing, like Sentry, for example, is also well underappreciated. But that helps a lot to just know what happens and what could have gone wrong.
Hmm. Interesting. Awesome. I think now is the time we go into the demo stuff.
Great. So yeah, I actually prepared a code search demo that we have built recently.
Okay.
Let me just share my screen.
Sounds good.
So first of all, Quadrant is an open source tool, and we also try to make all our demos open source. So you can see how this end-to-end applications were created, and if there is any magic inside, you can also see that easily. So our demo code search project is hosted on our GitHub organization, so you can easily find it. And there is a pretty comprehensive README of how to run it, what are the tools required for that, and some general description of how what is the process implemented inside. So basically, the whole goal of that project was to chunk the code base of
Mm.
Quadrant and allow
Okay.
you to find some relevant pieces using two different approaches. First of all, we used one of the general purpose sentence transformers, which is all mini LM L6
Mm.
V2, which is one of the standard models for
Yeah. Hugging
natural
Face, right?
language processing. Yeah, exactly. This is
Yeah.
part of the sentence transformers library, and
Hmm.
this is quite commonly being used in multiple demos because the model itself is pretty lightweight. It has less than 200 megabytes and
Hmm.
still provides pretty decent results, at least for English. But this is designed mostly for natural language processing.
Hmm.
So we cannot expect the model to really work for code. It's not going to understand, for example, Python code, which is based on tabs or spaces. I mean, indentation really matters in terms of Python code,
Right.
in order to be able to understand that properly. So we built one pipeline for processing the code and converting it into more natural language like. So
Okay.
here we are just taking the definition or the signature of every single method that we have in Quadrant's code base, which is written in Rust, by the way. And we remove all the code specific parts such as braces or
Hmm.
some sort of code syntax that is also present here. We also incorporate doc strings, which are pretty informative because they describe the idea to create a specific method and also justify some sort of choices we made to implement it. Then this is the first part. And then we
Yeah.
have a model which is specific to code search. So it was trained on some code corpora, and that
Hmm.
should already give us an understanding of what this particular piece of code is all about.
Hmm.
So the goal here is the first model should help us to find some relevant code snippets based on the name of the methods or maybe the names of the variables or parameters that were used in that particular method. Also, it should also support synonyms out of the box, so it doesn't matter that much if your colleague prefers to use different term for the same thing. You should be still able to find a relevant snippet. And the next
Okay.
model should rather provide you with some similar snippets based on queries which are more code-like. And then the process is pretty straightforward. We have those two separate pipelines, and we
Hmm.
send your query to both of them, and then we combine the results. So the description is pretty long. We have some diagrams here and also all the requirements, but eventually you are able to start the application, and there is also an online version available if you just want to try it out without doing all the steps in the meantime.
Okay.
Here you can provide all the types of queries you could possibly imagine for code search. That might be just a code snippet if you want to find some near duplicates, or
Hmm.
you can also select one of the predefined queries. If you don't know the code base of Quadrant, I do not. I have to say that. Uh, you can also use one of these examples, and here you can see the results that which come from both methods at the same time. So basically, these highlighted pieces are actually the overlaps of both methods. So one of the methods provided us with the whole function definition, and the
Hmm.
other one just pointed this specific piece of code that actually flashes the wall. So
Sure.
by combining those two methods, we are actually able to provide you with even more relevant results than if we just used one of them. But of course, some of the results are just returned by one of them, and then we do not have this yellow highlight at all. And
Hmm.
that's basically it. If you are interested in more details, there is also a tutorial on our website that you can check out, and it uses a completely different model for the code embeddings, this time from Gina AI, because they have trained uh, their own embedding models for code search, specifically, of course, for code search, and this is right now a state of the art in that domain.
Nice. Okay. Thank you. This was pretty cool. Code search. Got it. Okay. Before we end, I have one last question for you. Could you discuss, like we discussed so many things, like starting from basics of semantic search and RAG and the use cases and the challenges faced, optimization, productionization. So could you maybe discuss like the future improvements we can see or you see in semantic search?
Yes, definitely. So there's actually a lot of challenges, some open challenges in semantic search itself. And first of them is related to the fact that semantic search is thought to be memory intensive. I mean, if you
Mm,
have millions of embeddings, you also need gigabytes of memory available. So it's not possible for to implement that on a bigger scale if you have some strict budgets. So
mm,
that's exactly something that we want to try with Quadrant and our quantization methods we provide. And also, this is a pretty interesting direction. Like Cohere has released their new embedding models recently, and they
yeah,
started supporting scalar quantization and binary quantization directly. So you can uh, get quantized vectors already and reduce the
nice.
memory requirements by up to 32 times. And this is also up to 40 times faster. So this is one of the directions that I'm looking at. But also there are plenty of others like how to update our vectors. I mean, right now, if you have a specific embedding model, if you create the vectors out of your data, you put them into the vector store, and
Hmm.
you actually assume that this is never going to change. But computing the vectors is still a challenge that takes a lot of time because we are just processing gigabytes of data through an embedding model, which is, of course, it might be fast, but still the process takes some time. This simply adds up. So once you decide that you want to use a different model, you need to do the same process again.
Mm,
Uh, if there is a different way, maybe of recalculating the embeddings, maybe in a faster manner, like some sort of translation between the vector spaces. I can imagine that would help a lot of people because this industry is changing so rapidly. There are new models being published every single day. The leaderboards are updated with the some new models every week, so you can see that there is progress going on. And if you decided to use a specific model a few months ago, you might be just losing some quality because some people were able to train a different one. So I would
yeah.
say this is also a challenge, but there are many, many more. And there are also some other useful strategies of using vectors, not only for search, but for recommendations and to perform some sort of exploration of that vector space. So I feel like there is many, many other use cases that we could enable by providing some tools to our users.
Awesome. Well, thank you for sharing. Definitely learned two new terms today: extreme classification and raft. I'm gonna find that out. If you can share the paper link, that would be
Yep,
wonderful.
I would do that just right after our meeting today. But
Awesome.
this has been published like within last 2 or 3 days, so I'm not sure.
Okay.
But this is
Oh, okay. Yeah,
definitely
it's pretty new
pretty new
then.
to, yeah, it is.
Okay. Awesome. Well, thank you so much, Casper. Hope you had a wonderful time and have a good evening.
Thanks a lot, and that was a pleasure.